I need to find the maxima, the extrema of this particular function. And again, I'm going to start with the domain. So I'm looking at denominators, radical signs, logarithms, no radical signs, no logarithms. I do have a denominator. And I know that this denominator cannot be equal to 0. So I'm going to set it equal to 0 and see if I have any values of x that make the denominator 0. So I have x squared plus 2x plus 2, and I want to know if that equals 0 at any point. Well, I can see that this is not factorable. So in order to find out if there are any zeros, I'm going to use the quadratic formula. And I always like to start with the discriminant, which is b squared minus 4ac. Because that tells me right away whether there are 2 positive roots, 1 positive root, or no roots. I shouldn't say positive, real is what I meant. So b squared minus 4ac would be 2 squared minus 4 times 1 times 2. Well, that's 4 minus 8. That's negative 4. So this is telling me there are no real roots of this denominator. There are no x values that are going to make it equal to 0. Well, that's really a good thing to know, because now I know that my domain of this is negative infinity to infinity. If there's no place that the denominator can be equal to 0, then every x value is going to be good. So let's erase this to give ourselves some room. I'll delete that. I will put our domain up here. Domain equals negative infinity to infinity, just so that we remember. And now I need to find the derivative. I need to find y prime. You know, before I do that, I'm going to comment one other thing about this function. This is a rational function, and it is a proper rational function. The highest power of the numerator is larger than the highest power of the denominator, which means I'm going to have a horizontal asymptote at y equals 0, the x-axis. So that's an important thing to know, an important thing to remember. So to find y prime here, I'm going to have to use the quotient property. So uv minus uv prime over v squared. So the derivative, this is my u, this is my v. So the derivative of x plus 1 is 1. And I'm multiplying that times x squared plus 2x plus 2. And I'm subtracting from that, just made myself a little bit of space, u, which is x plus 1, times the derivative of v, which is 2x plus 2. And all of that is over x squared plus 2x plus 2 squared. We really need to simplify in order to find out where we're going to have any zeros in the derivative. So y prime is equal to, well, this is x squared plus 2x plus 2. I don't need the times 1. Minus, I'm going to FOIL this out. So I get 2x squared plus 4x plus 2, and that again is all divided by x squared plus 2x plus 2 squared. More simplification. Y prime is equal to x squared plus 2x plus 2 minus 2x squared minus 4x minus 2, again, over x squared plus 2x plus 2 squared. So, combining my like terms, y prime, well, I have an x squared and a negative 2x squared. That's going to give me a negative x squared. And I have a 2x and a negative 4x. That's going to be minus 2x. And a plus 2 and a minus 2, those are gone. Divided by x squared plus 2x plus 2 squared. And if I want to find out where this derivative is equal to 0, I don't really have to look at my denominator, and I already know that my denominator can't be turned into 0 from earlier, but I just need to know, well, where is negative x squared minus 2x equal to 0? So I think I'll factor out a negative x. So I get negative x times x plus 2 equals 0. And I find out that I have a critical and stationary point at x equals 0 and at x equals negative 2. They are critical and stationary because the derivative is equal to 0 at those points. So let's find out what those actual points are. Here's my function. I moved it over there so that we can look at it. And if I want to find f of 0, well, that's going to be equal to 0 plus 1 over 0 plus 0 plus 2. So f of 0 is 1/2. So I have one of my points is the point 0, comma 1/2. The other thing I need to do is for f of negative 2. So that's equal to negative 2 plus 1 divided by negative 2 squared plus 2 times negative 2 plus 2. So that is negative 1 over 4 minus 4 plus 2. So that's negative 1/2. So I have the point negative 2, negative 1/2. Those are my 2 points. I'm going to write them down here in black. So I have the point 0, please work. Why are you not working? Try again. I have the point 0, comma 1/2, and I have the point negative 2, comma negative 1/2. Now what do I know about my graph? I know that my graph has a horizontal asymptote right along the x-axis. So y equals 0 is a horizontal asymptote. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know that I have one turning point at 0, 1/2, and another one at negative 2, negative 1/2. Those are the only places my graphs could turn. And I also know from my original function that I have another point that I'm aware of. I know where x is equal to negative 1, y is going to be equal to 0, because that will make my denominator equal to 0, my numerator equal to 0. So I know I have another point on this graph. What did I say? Negative 1, 0. So I have another point on this graph right here. There is no other point where the graph can cross the x-axis, except for at that point right there. That is the only point where y is equal to 0. And this point right here, I know is a turning point. It's a relative maximum or minimum. And I have an asymptote of y equals 0. So I know that my graph is going to be coming along underneath the y-axis, because it has to get to this point here without crossing the y-axis. It's going to turn there. It's going to cross the x-axis right there. It has to turn here, and then it has to go along the horizontal asymptote forever. So your knowledge of how the graph works really lets us know now that this point right here is a relative minimum, and this point right here is a relative maximum. It's just like a super neat puzzle.